Hi, I'm currently working on a video that will show how to write a production rule solver for Minesweeper Sudoku. It's going to probably take a few weeks to get it out. I have a lot going on right now, so I thought I would do an easier video to tide you over. This is puzzle number 2. In the last video on this topic, we generated it along with 999 other puzzles using a brute force solver. OR tools specifically. And I know that this puzzle is solvable because I've already solved it on paper. So now I'm going to walk you through the solve of it. And in the course of doing so, we'll identify some rules that we can use to solve the puzzle. And then when we get to the next video, we'll implement many of those rules in code. So when I look at this puzzle, the first thing I notice is the 3 up in the upper right-hand corner. So just to remind you, this puzzle is basically like a game of Minesweeper. Each row, column, and 3x3 block will have 3 mines, and the clues indicate the number of adjacent mines to the square that the clue is in. So I know that there are 3 mines adjacent to this 3 somewhere in these 5 neighboring squares. Those 3 mines will be the 3 mines that appear in this block, so we can eliminate the squares that aren't neighboring the 3. Once we've done that, the 3 here is the same situation. It's going to have 3 mines all in this container, and we can eliminate the squares that aren't neighbors to that 3. Having done so, I can see that this 2 now only has 2 possible cells where we can place mines, and it needs 2 mines. So let's go ahead and place them. There's one. There's the other one. This 2 also only has 2 possibilities for mines. Let's place those. This 2 now has both of its mines placed, so we can eliminate its neighbors. Moreover, this column now has all 3 of its mines, so we can eliminate the remaining square. This column has 1 mine and only 2 other unknown squares, so the mines in this column must go in those unknown squares. So at this point, on this side of the puzzle, we've got 6 mines placed. There's 2 mines here, so there's going to be another mine that goes here, 2 mines there, so another mine that goes there, 2 mines here, so another mine that goes here. Now, looking over at this block here, there's something interesting going on. This 1 can only have a single mine as a neighbor, so these 3 cells may or may not have a mine in them. And the same situation with this one here. These 3 cells may or may not have a mine. Now, if these 3 cells didn't have a mine, then we'd have a single mine here and a mine there, and we'd only have room for 2 mines. So a mine must go in there, and a mine must go in there. That's 2 mines, and that means that this cell here must be the 3rd mine. Because a mine is forced here, we can rule out the cells that are neighboring the 1, and the cells that are neighboring this one, similarly, can't have a mine. Also, I can see that I can't put a mine in the center square here. Because if I did, it would finish both of the 1s, and then we wouldn't have room for a 3rd mine. So we can rule that out. I'm going to go ahead and erase the little marks I made because they're not really buying me much at this point. So that's what we've got. Now, I can see that there is a row here that only has 3 open squares. So let's go ahead and put in those mines. This 3 here only has 3 places where I can place its mines. So let's go ahead and place those. That completes this block. This row here only has 2 mines left and 2 unknown cells, so we'll go ahead and place those. That completes this 3. So we can clear its other neighbors. There's going to be a mine in this row in one of these 2 squares. This 4 already has 2 mines. It needs 2 more, and they're going to go in one of these 3 squares. So 2 mines in that run. 2 mines there, 1 mine there, which means that we can eliminate all the other cells in that row. I'm going to go ahead and erase my marks here. We know that a mine must go in one of these 2 cells here. Now looking at column 2, we can place some mines in the remaining squares. Okay, this is a little more subtle. This would be a more advanced rule, but I see a way to make progress up here. If you look at this block, it already has 2 mines. That means only 1 more mine can go in this area. This 3 needs a mine in one of these 2 cells. It can't have 2 mines here, because if it did, there would be 4 mines in this block. So there's got to be a mine there. We can eliminate all the other cells in that block. And that forces another mine for this 3 that's got to go here, which finishes up that top left block. There we go. So now our top row is finished. So we can finish up this one. Also, there's a mine here. Which finishes up that block. Our first column we can finish. I think things are going to go pretty rapidly at this point. That column is finished. We're going to, because this column is finished, there's no mine here, and the 2 mines that have to go in this run go here and here. Now we can finish up this column. There we go. Finish up this row. Finish up that block. Now this 3 already has its 3 mines. So we can eliminate that square, which forces a mine here, which finishes up that row, and then this row gets its final mine. And that solves the puzzle. So when we're working on the production rule solver in the next puzzle construction video, I'll show how to use the different rules that we used just now to solve this puzzle in code so that we can reproduce not necessarily exactly the same solving order, but something relatively close to it. I'll see you then.